has come for today. This is a nice tribute to Brad to have all of you here. And in order to introduce Brad, I've asked Colin Englefield, his department chair, to have those honors. And I told Colin if he wanted to tell some stories, he could do that too.
Thanks. All right. I'll be brief, but it's a pleasure to introduce my friend and colleague, Brad Carroll. Thank you. Thank you. So I was thinking back to when I first met Brad. So it would have been 1998. I was here as a visiting professor, and I had a meeting across campus, and it was raining, and I commented I didn't have a raincoat, and so Brad said, well, I have an umbrella you can borrow. I thought, wow, what a great guy. And turned out that umbrella was shaped like a duck. So I went across campus to my first big meeting with an umbrella shaped like a duck. And then I remember that the other thing I learned about Brad right away was that he really liked Buffy the Vampire Slayer. So that was my first impression of Brad, was that he was the guy that had the duck umbrella and liked Buffy the Vampire Slayer. But Brad is a lot of different things to different people. And if you're in the physics department, he's a colleague and a mentor and the go-to guy when you don't know what to do. And if you're a physicist, he's a scholar in astrophysics and a textbook author. If you're in the Greater Ogden area, he's probably your yoga instructor. He's so many things, but to students, what I always hear is he's their favorite teacher. I had a number of students come to my office this year and sit down with me and try and rearrange their whole schedule just so they could take one more class from Brad Carroll. And that's what I always hear. I sent out some notes to a few students asking them for thoughts about Brad, and one that struck me was a note from Janica Cheney. So she told me she had never taken a physics class in junior high or high school, came up to Weber State, decided to major in computer science, and then in about the first day in Brad's physics class, listening to him, she said, this is it. This is what I want to do. Switched her major to physics, is now, of course, Dr. Janica Cheney, and works at ATK as the director of safety and mission assurance. I don't know what that is, but it's probably a pretty big deal. But that's who Brad is. He makes a difference for students. Won numerous awards for teaching and scholarship. Most recently, the Brady Distinguished Professor, and I can't think of anyone better suited for that title. So, Brad Carroll is the best.
Woohoo, I have to figure out how this Madonna mic works. There we go. That should do it. And this I can just set aside. Well, thank you all for coming. I'm delighted to see, I'm surprised to see a room full of people, and delighted at the same time. And before I begin, I want to thank the folks at the Teaching Learning Forum for giving me this great gift. And it's actually greater than they know. Most of us are so busy racing around, hurdling, just trying to put one foot in front of the other. just trying to keep our balance so we don't fall. And we very rarely get the chance to reflect and look back on where we've been. And I've learned a lot preparing for this talk. You know, the last lecture is supposed to be something that a professor never has the opportunity to present to a typical class. And I've been here for 30 years, which amazes me. And I've had the privilege of working with a lot of people. Okay? The Reddit Actual Advice Mallard recommends what has worked really well for me. If you want to perform well in life and achieve a lot, surround yourself with people better than you. Okay? The physics department faculty have made this advice really easy for me to follow. Okay? This right here is last year's incarnation, and I've had the pleasure of working with immensely talented people, both within the department and outside the department. And here's a word cloud of all the people that I've worked with on research, or with whom I've either taught or with whom I plan to teach. And all of you, all the members of faculty out there, are just exceptional people. You know, we've devoted our lives to our disciplines, and we've, you know, worked on trying to advance them and pass on what we learned to the next generations. And over the years, our devotion to our disciplines has really changed us. And it's had a profound effect on our lives. And to a large extent, this devotion has shaped our lives and our worldview. Okay? But most students just pass through. They're just trying to navigate the currents of our class. If we want to share what it means to be an astronomer or a historian or a piano player, and we should share it, then we have to initiate that conversation. And so that's what I want to do here in my last lecture. Okay. So I want to talk about 3 journeys through time that I've made using 3 different time machines. Okay. One is nearby, one is a short walk from here, and one is parked in orbit. Okay. The first of these time machines is, of course, myself. We all carry ourselves through time, from birth till death, and in my case, the trip has lasted 65 years. Okay. Remarkably, though, we've all ended up here together, although we began our journey in vastly different worlds. Okay. I was born in Hagerstown, Maryland, right there, at the end of the first half of the last century. My father came from Western Maryland, a little coal mining town called Westernport. My mother came from Front Royal, Virginia, which is down around here on the banks of the Shenandoah River. Hagerstown lies among 3 Civil War sites, or several Civil War sites. There's Gettysburg, Antietam, Harper's Ferry, South Mountain. And you can't grow up there without knowing something about the Civil War. When I was born, there were still 68 veterans of the Civil War alive. 68 people remember the horrors of battles like Antietam, where nearly 21,000 soldiers were killed on a single day in 1862, killed or wounded. It was a different era back in 1949. Gas cost 26 cents a gallon. Wow, that sounds low, but that's $2.59 in today's dollars. So today, gas is actually cheaper than it was when I was born. Actually, I grew up in the town of Halfway. Here it is. It's halfway between Hagerstown and Williamsport. You know, that's the name of the town. And I used to go fishing on the Potomac River there with my father and grandfather. Okay? In my family, there were my parents. There they are. And my brother, Jan, who now goes by his middle name, Rob. And this was taken on our way to church for Easter. Women always wore gloves to church in those days. And my father was an accountant at Fairchild Aircraft. Mm-hmm. Both my parents went to business college, but nobody on either side of the family had an academic background. We didn't have a lot of money, but we certainly weren't poor. My dad is now 93, my mom's 91, and they both are managing to live at home with my brother's help. And I just thought I'd show you a picture of them on their 70th wedding anniversary last year. Yay! I agree. We didn't have iPhones then, oh my gosh. But I remember my family passing around our new telephone for the first time to hear what a dial tone sounded like. They had these little holes you could put your fingers in. Oh my gosh. You know, computers and even television at first were strangers to our home. But what we did have was our creative imaginations. I spent my first 10 years and halfway playing in woods like these. Every day, the neighborhood kids would meet and head into the woods and play and imagine ourselves the heroes of comic book adventures or cowboy stories. And whenever the wind came up, I would climb up high into a tree, and the wind would blow me back and forth, swaying in the wind. And it was wonderful. I still know every path through these woods, and I would recognize that tree right there anywhere. Or I would know them if they were still there. A huge mall has replaced them, and these great woods have been reduced to a tiny sliver of a little neighborhood park. I really enjoyed elementary school. There's my third grade class. I'm not in there, I took the picture. So don't try to find me. You know, I don't know what awakened my interest in math, but I remember my father teaching me how to take square roots by hand. This seemed like magic to me. I discovered that math came really easily to me. And, you know, I remember the thrill of learning how to read and what a joy that was. But I don't remember learning how to add, subtract, and multiply and divide. It always just made sense to me. But I've always felt that I wanted to share what I learned with others. Sometimes I held little mini lectures down in my basement. And I would talk to my parents in professorial tones about something or other while they sat on the stairs of the basement. My parents gave me a refracting telescope, one with lenses, when I was 9. It was really more of a toy than a serious instrument. I looked at the moon and at the stars, and my cousin spoke of the stars as being dazzling beauties. I was a Cub Scout, a rather dour Cub Scout, but I was a Cub Scout. And I have a vivid memory of a skit that I did with another scout for a pageant at school. I played a husband, he played a wife, and we were in a restaurant looking at our menus as she read aloud. And every time her reading would go lower on the menu to more expensive things, I would simply extend a finger and push the menu down to bring her gaze up to the least expensive items. You know? And we did this several times. She would read the more expensive, I would push her menu down. And every time, that just got a big laugh from everybody. And that made a big impression on a shy kid like me, that I could have such an effect on an audience. I'll just never forget that. There's one other thing I should mention about this Cub Scout skit. I performed it in blackface. Our faces were blackened with burned cork. In Hagerstown, these were the days of the minstrel shows at the Lions Club. Okay. As I discovered in preparing for this talk, the PTA of my own Lincolnshire elementary school held their own annual minstrel shows. I lived in a white world, as you could tell from my third grade class. I only saw African Americans when I went into town with my grandmother for shopping. There, typically, we would see elevator operators like these at department stores. Is that me making that weird noise? It is. How can I stop myself from doing that? Do you have some? Okay, we're just going to put this in the back pocket. We're going to put that in my back pocket? Okay. We're going to rotate this just up. Okay. That should do it. Okay. I won't move. I shall not move. No. You're right, I moved. So if I take this out and I just lay it on the podium, will that work? Oh, I see, it's the plug here, apparently.
Right.
I'll rotate it and see. There, okay, now it's fixed. Technology, rotate the plug and it works. Okay. But, you know, these were the African Americans that we ran into at department stores. I think I'll give up on this. There we go. Can I switch to the other mic? Oh, apparently it's up here too. There we go. Is it on? Hello? Okay. Yay! I thought somebody was dropping, you know, big baggage in the back of the room like they were moving in. Okay. But I really didn't understand why wearing blackface would be considered funny. But honestly, it didn't bother me either. There is one thing that troubled me, though, and it troubled me quite a bit, and that was these drinking fountains. I simply couldn't understand why there had to be two separate drinking fountains for whites and blacks. It made no sense to me at all. So I really did begin my life in a different world. Since then, I've seen so much progress in civil rights. I'm going to hold this. Since then, I've seen so much progress in civil rights and gender equality. And it's still not enough, but this progress makes me optimistic about the future. But I want the message that I want students to hear is that every culture has its blind spots. Every culture's first obligation is to replicate itself. And that means that that goes complete with beliefs and attitudes that might better be discarded. Your society surrounds you and enfolds you and ultimately suffocates your ability to question attitudes that might better be discarded. So sometimes you have to listen to that questioning voice in your head that's asking, what is that? Why is it like that? What is its real purpose? Think for yourself, move beyond your worldview, and seek the answer to those very important questions. Let me move forward again in time. I had asthma and it was not improving. I spent my 10th birthday in the hospital in an oxygen tent. My parents took advantage of an opportunity to move to Yuma, Arizona, and here they are. There was hardly a tree to be seen. The Colorado River west of town, wow, I just pressed something amazing. Okay. The Colorado River west of town was too thick to drink and too thin to plow, and not at all like the Potomac River that I had fished. I didn't like Yuma at all, and I longed for the woods. But my asthma improved, and you know, in preparing for this talk, I realized that moving to Yuma removed me from the racially poisonous atmosphere that was in Hagerstown at that time. You know, you have to be taught to hate, and I was very lucky to have escaped that lesson. We stayed in Yuma for 2 years, and then we moved to Anaheim, California. There were still no woods, but there were at least orange groves. At least there were then. My family attended the local Lutheran church, and this is my confirmation picture. I became an acolyte, meaning that I lit the altar candles at the start of the service, and that I sat behind the pulpit as the pastor delivered his sermon. And for a while, I even toyed with the idea of becoming a pastor. I liked the idea of talking to people every week about things I thought were important, like love your neighbor as yourself. For Christmas in 1963, my grandfather gave me a telescope. And I could actually see the weather bands of Jupiter and the rings of Saturn. In high school, I majored in math, I marched in the band, and I continued being terribly shy. You know, I used to think that I majored in math because I was lazy, and I was. It took almost no effort for me to manipulate the equations we studied. However, I've come to appreciate that I have an emotional and aesthetic connection to math, just as surely as I do to music. You know, reading math, elegant math, is mentally stimulating, but I also find math comforting. Reading mathematics gives me the feeling of being safe and secure. I still read a lot of popular math today, and perhaps for the same reasons. After graduating from high school in 1967, I went to the University of California, Irvine, to major in math. There we go. And that is the campus at the time. How many have been to Irvine recently? Or ever? It doesn't look like that anymore. Lots of open space. I discovered physics at UC Irvine. I remember where I was sitting in the lecture room when Kepler's second law of planetary motion was derived from Newton's laws of motion. And that derivation changed my life. I knew if I wanted to understand fundamentally how the world works, I would have to understand physics. I was hooked. My discovery of physics came too late, though. By the time I graduated in 1971 with a bachelor's in math, I had finished only 5 quarters of physics, the basic introductory calculus-based physics course. I knew I wanted to teach, so I went for another year to earn my standard teaching credential, which qualified me to teach math and physics. Along the way, I met my wife Lynn at UCI when she bought my used German book. And later, you never see that in the movies, do you? We'd known each other, we got to know each other, and we watched several of the moon landings together. Nobody would rent TVs to the men's dorms, and so we had to go over to the women's dorms to watch anything on television. And it was a real thrill to shake Neil Armstrong's hand back in 1988 at Weber State's 100th commencement. Back to UCI. After I got my teaching credential in 1972, Lynn and I were married. This is the awe moment. Thank you. I was hired to teach math and physics at Highland High School in Bakersfield, California in 1972. And here I am with some of the physics demos I used. Actually, that's all the physics demos I had to use. And I honestly should not have been teaching physics. I really shouldn't have been. I knew so little. But the more physics I taught, the more I wanted to learn. And after 2 years of teaching high school, I asked Lynn what she thought about me quitting my teaching job and applying to graduate school in physics. She could very reasonably have said no, and that would have been the end of it, but she said yes. And that was probably the second most important yes she's ever said to me. I bought a copy of Halliday and Resnick, the basic physics book at the time, and taught myself enough physics to take the graduate record exam. We flew to Boulder, and somehow I talked myself into the University of Colorado. The first person I met there was Carl Hansen, and he went on to become my thesis advisor. Meeting and working with Carl was just an incredible, incredible stroke of luck. At Colorado, I earned my master's degree in physics and my doctorate in astrophysics while Lynn finished pharmacy school at the top of her class. And under Carl's guidance, I completed my thesis on the non-radial stellar pulsation in the presence of slow rotation. Carl arranged a postdoctoral position for me with his friend Hugh Van Horn at the University of Rochester in upstate New York. And that was another incredible stroke of luck. After 4 years there, I arrived at Weber State College. After submitting what I'm sure is the most hopeless application the physics department has ever received. It consisted of just a brief one-page cover letter and a list of 3 references. No statement of teaching philosophy or research interest at all. Okay? I am convinced, absolutely convinced, that it's only because Dale Ostley was here and argued for a colleague in stellar pulsation that I was invited here for an interview. That's incredible stroke of luck number 3. After interviewing here, I called Lynn and described the physics department by saying I felt like I had stumbled into a gold mine. And here I am. Okay. Dale and I wrote a book together, An Introduction to Modern Astrophysics, and that is now the standard text for upper division astrophysics courses taught everywhere English is spoken. Oh, that's Weber State College. Okay. I did not write that. I did not write that. There's Dale. I've just been going along here having a good time, and you folks have been out there not saying anything. Hey. But there it is. Thank you for letting me know. I have something in each hand, and that's really too much for my brain right now. You know, but I will say it has been translated into Korean. And I'm mentioning this to brag. Not about myself, but about Weber State's astronomy group. If you go on Amazon and you ask, what is one of the best-selling introductory astronomy texts? It's Understanding Our Universe by Stacy Palin. Yay! Okay. And if you ask, what is one of the best-selling graduate astrophysics texts? That's Stellar Interiors by my advisor, Carl Hansen. And so the next generation of astronomers are going to get their first taste of astronomy from Stacy's book, their in-depth knowledge of astrophysics from Dale and my book, and then the graduate training from Carl's book. I don't want to leave out John Armstrong. Okay. You can read about his research on superhabitable worlds in this month's issue of Scientific American. Okay. We're all connected, and Weber State astronomers are responsible for inspiring and educating the astronomers of tomorrow. And I think that is really amazing. The real point I want to make here is that life is just so contingent on luck and circumstance. If Lynn hadn't encouraged me, if I hadn't met Carl Hansen, if he hadn't known Hugh Van Horn, if Dale hadn't been here to argue for me, I wouldn't be standing here or have written a book. The race really is not always to the swift, and some people like me don't take the direct route. I've always had an eye out for late bloomers in my classes, people who haven't quite discovered how good they really are or really what they want to do. And there are some students on whom I would have bet a large sum of money that they were lost causes. Really. But I supported them anyway, and they rose to become among the stars of our physics graduates. No, really, all faculty have tales like this, right? All faculty have tales like this. Okay. We should help our students not just to celebrate their success, but to recognize the contingency of their own path, if for no other reason, so they themselves will provide a helping hand to the seemingly lost causes they will encounter later. Well, so much for my own personal travel through time. The second time machine is just across the corridor, and it is the library. What is a library? It's a conversation extended through time. Okay? You can admire the astronomy in the 4,000-year-old Gilgamesh. You can honor the first questions asked by the pre-Socratic philosophers. What is the essential nature of things? How many things are there? What are they made of? The Upanishads, the sacred text of Hinduism, reveals a worldview that really resonates with me, as does Lucretius's On the Nature of Things. If you read Galileo's The Starry Messenger, you encounter a startling modern scientific mind who has just discovered that Earth is not the center of creation. So I'll admit it, I'm an unabashed bibliophile. Bookstores were in common when I was growing up, and I remembered the thrill of looking through the catalog of the Scholastic Book Club and ordering my first books in 1962. Okay. These are two of the first books I bought. There's Arthur C. Clarke's Against the Fall of Night. It's a big concept story about a young man in the far future who discovers his destiny among the stars. And I just reread it, and it still leaves me in awe. And the second book is the Tao Te Ching, which I basically bought for its cover. But the first two lines of that have stayed with me. There are ways, but the way is uncharted. There are names, but not nature in words. There are names, but not nature in words. I've thought a lot about that over the past several years. Okay. So let me ask you, if you were to have one book to take when you were stranded on a desert island, what would it be? Here's mine, Thomas Pynchon's Mason and Dixon. Okay? This is a funny and a profound examination of measurement and ownership through the eyes of two astronomers and surveyors, Charles Mason and Jeremiah Dixon. I'm just making a recommendation up here. You know, maybe we should all do that, share what we read with our students. I'm going to stop preaching to the choir now. Okay. The third time machine parked in orbit is the Hubble Space Telescope. Why is a telescope a time machine? Well, light travels about a foot in a nanosecond, a billionth of a second. So when you're out there watching this talk, you're seeing me as I was a few billionths of a second ago. Okay? The moon is about a light second away. So when we see the moon as it was a second ago. Oops. Okay. Technology, there's two sides. How hard can it be? The sun is 8 1/3 light minutes away. And so we see the sun as it was 8 1/3 minutes ago. If you go out on a dark night, you'll see countless stars like these over Capitol Reef National Park. And oh, it's good. You can actually see the stars. It's dark enough. Okay? All of these stars are members of our own Milky Way galaxy, meaning that they all orbit the center of our own galaxy just as the sun does. The Milky Way has about 100 billion stars, and that's a hard number to wrap your mind around, so it's roughly the number of seconds between now and the Trojan War in the 12th and 13th century BC. Recently, we learned that there are at least 17 billion Earth-sized, but not necessarily Earth-like planets in our own Milky Way galaxy. Just think of what the possibilities are. Stars brighter and close enough to see are, just look like they're bright points hanging in the inverted bowl of the nighttime sky. But really, they're at all different distances from us. If you go out tonight around 9 o'clock, you'll see the constellation of Orion. And all those stars, although they look like they're just painted on the sky, are at different distances. The nearest one is Bellatrix up there. And when light left that star, the American Revolution was brewing. At that time, Samuel Adams and Joseph Warren were setting up the first committee of correspondence. The most distant star is Alnilam, the middle star in Orion's belt. And when light left Alnilam, the Prophet Muhammad had recently died in 632 AD, and the split between the Shiite and the Sunni factions was widening. But if you look back at the sky as it appears from Capitol Reef National Park, like right there, you'll notice that there's this broad band of stars stretching from horizon to horizon, and that is our own Milky Way galaxy. It appears as a band because we are in the disk of the Milky Way galaxy, so we have an inside view of it, sort of like a pepperoni's view of pizza. The center of the Milky Way is 27,000 light years away from us. And when light left the galactic center, the last ice age was nearing its peak, and unknown hands in the Paleolithic period, the Old Stone Age, were making this the woman of Willendorf. Now, there's one object here in the sky of Capitol Reef that does not belong to our galaxy, and it's this little smudge with a little bright dot at its center. Okay? That is the Andromeda galaxy. This is our nearest neighbor spiral galaxy, and it is 2.5 million light years away. And it's the farthest thing you can see with your naked eye. When light left the Andromeda galaxy, the first tools were being made by our human ancestors, probably this guy. That tool right there is about 2.5 million years old. Okay? There's roughly as many other galaxies in the universe as there are stars in our own galaxy, at least 100 billion. Now I want you to look at this photo here of the moon. And there's a little square there, empty, doesn't look like there's anything there. What the Hubble Space Telescope did is that it viewed this area, and it exposed its electronic detectors to that sliver of sky for nearly 23 days. And this is what it saw. This is the Hubble Extreme Deep Field. Every point of light you see is a galaxy that is incredibly faint and distant. Light from the farthest galaxies have traveled 13 billion years to reach us. And that means the light left when that galaxy was when the universe was only 800 million years old. And that's why telescopes are time machines. When we look at this ancient light, we see our universe like it was when the light left. And so we can actually see the ancient universe in the same way we see anyway, after the light has had time to reach us. Paleontologists have to reconstruct extinct animals and fossils based on their fossilized remains, but astronomers can watch objects like these galaxies exactly like they were at different ages by viewing them at different distances. Okay? And what do we find when we do that? Here are some of the most remote galaxies that the Hubble saw, and they're not like today's galactic islands that are just floating in a vast emptiness. These galaxies are colliding with each other. They look disturbed. They're in the process of being drawn together by gravity. They're chaotically colliding. They're drawn together by gravity, and finally they're going to settle down into the mature galaxies that we see in the universe today. So the universe has changed with time. It has evolved. And astronomers use their telescopes to travel in time. We can watch how primitive galaxies evolve into today's mature galaxies. So we map these galaxies out in space. And what do we see? We find out that they're gathered in clusters. This is the Hercules cluster of galaxies, a relatively nearby cluster of galaxies. And these clusters are collected into superclusters of galaxies. And these superclusters are collected into this overall pattern. There's filaments of superclusters of galaxies surrounding large empty areas, like that right there, called voids. And what's going on here? How did the universe get to be this way? You know, how did the universe evolve from the chaotic beginning you saw in the Hubble Space Telescope photo to this? Well, in 1929, Edwin Hubble discovered that all of the galaxies in the universe are moving away from each other, faster and faster. Galaxies further from us are moving away faster, and so all we have to do is trace the expansion backward in time. Just reverse the arrows and follow the motion. And we find out that 13.8 billion years ago, all of the galaxies were at the same place at the same time. And this simple observation tells us that the universe expanded from an unimaginably hot and dense beginning, which astronomers call the Big Bang. And so here, this looks like a history of the universe. It starts out with the Big Bang. The first stars form, stars and galaxies develop, and then inside those stars, complex atoms are manufactured. And then those complex atoms are expelled into space as those stars explode. And these heavily seated, these atoms gather into clouds of interstellar gas and dust. And these clouds of gas and dust gravitationally collapse, and they heat up, and they form a newly formed star that's surrounded by a disk of gas and dust. And this is an infrared picture, an actual photo of the star HL Tau in the constellation of Taurus. And it shows a disk of gas and dust. And these blank areas are where the gas and dust are being swept up by planets in the process of forming today. And that is just like our solar system formed about 4.6 billion years ago. 4.5 billion years ago, a Mars-sized object slammed into Earth and tore away the moon. Earth quickly cooled and life evolved some 3.5 billion years old. 65 million years old, an asteroid hit Earth and left this huge crater off the Yucatan Peninsula in Mexico. And the resulting devastation hastened the demise of the dinosaurs and allowed mammals to flourish. This led to early humans who dispersed from Africa in a way we could trace using mitochondrial DNA. Agricultural and settlement sprang up, along with the first art and literature. And from there, we can follow the stories in our libraries. This journey forward through time from the Big Bang culminates in our lives. And we know the broad outlines of this story, from the first microseconds of the universe to us right here today in this room. And much of this story has been revealed in our lifetime. And in fact, we are the first generation ever to have this grand perspective. So, is this hubris? Is this the pride that goes beyond before the fall of astronomers, to think we know it all? Well, the Big Bang made a big noise. And the reverberations of that noise left an imprint in the oldest light we can see, the cosmic microwave background. That's a remnant of the Big Bang. And we can analyze these blue and orange regions, slightly hot and cold by about 100,000th of a degree, and we can analyze those regions to find out what the universe is made of. And so we can look at the noise of the Big Bang, and here it is. Here is the fundamental tone of the Big Bang. Here's the first harmonic, here's the second harmonic, third harmonic, fourth harmonic. The red dots are the observations, the green line is the theoretical fit. That is dang impressive. I wish I could take credit for it, but of course I'm just here telling you about it. Okay? And so the agreement is astonishing, and it tells us a lot about how the universe is constructed. And it turns out nature has played a trick on us. After all the years, we've been studying the pretty shining bits. Stars, galaxies, and clouds of gas and dust make up ordinary atoms, made of ordinary atoms. But that makes up only 5% of the universe. We haven't even been looking at the other 95%. 27% of the universe is in the form of dark matter, and we know almost nothing about that other than how it acts gravitationally. The other 68% is dark energy, and that's a mysterious energy that fills all of space and causes the galaxies to recede from us faster and faster, exponentially. Einstein introduced this idea into his equations, but we have no idea what dark energy is. When the best theorists try to figure it out, they come up with a number, and they can compare it with the measured value, and it's only off by 120 orders of magnitude. That is one followed by 120 zeros. So really, we're in no danger of hubris, because nature keeps us humble. But if you put this recipe into a computer, 5% ordinary matter, 27% dark matter, 68% dark energy, and you start at an age of about 12 million years up there, and you put in some physics, and you let time run forward in the computer, you come up with a structure of the universe that looks exactly like what we see. Filaments of superclusters surrounding empty voids. And if you zoom in to one of those little areas, you see galaxies that just formed naturally. And galaxies of all types in just the right proportion and just the right groupings, very nearly. And so, the recipe works. We know how the ingredients behave, we just don't know what physically the ingredients are. There are names, but not nature in words. So let me leave the Hubble Space Telescope now and reflect on how everything I have lived and learned has affected and shaped my worldview. In the early 1990s, Lynn and I were out car camping at Fish Lake. And I was working on the first edition of the astrophysics text at this time. I sat outside our tent, there I am, just sitting, and reading one of the many astronomy books that I had brought along. And Lynn was going around bird watching and taking this photo. And in this book right here, I read, at this instant, all the matter we now see in the universe, comprising some billions of galaxies, was compressed within a sphere of radius equal to 1/100th of a centimeter, the size of the point of a needle. Well, I looked at the period of that sentence for a long time, and then I looked out at our camp and the trees and the lake and the sky and the sun that was shining and the planets I knew were there and all the galaxies. And I asked myself, do I really believe this? No. And I thought, if not, why not? All of the observational evidence, all the simple mathematics leads directly to this result. And I concluded that, yes, I was convinced by the evidence. When I say I believe in the Big Bang or in anything scientific, I mean I've evaluated and I trust the evidence. And as my understanding of the universe grew, the God I knew as an acolyte slipped away. I couldn't reconcile the grandeur of the universe with a God who worries if we wore clothing made of wool and linen woven together. It's not that I had a crisis of faith or anything. My religious beliefs simply fell away and became irrelevant. I saw a universe that didn't care, and I boiled that down to the phrase, the mountains don't care. That phrase, the mountains don't care, actually brings me great comfort. The mountains don't care, and by extension, the universe doesn't care. In my view, if something bad happens to me, it's not because the universe was upset with me or punishing me for something I did. And if something good happens to me, it's not because the universe has rewarded me or found me especially virtuous. Good or bad, I either caused something to happen or it happened for some other reason beyond my control. The mountains, in my view, simply don't care. So if I'm not a religious person, then what do I believe? I think one of the most meaningful things you can do with your life is to develop your own personal philosophy. And I've boiled mine down to 3 rules of 3 words each. I love you, to simply love as much as possible my fellow humans. Let me help, to offer my help to those in need, and do unto others, the golden rule that's common to so many beliefs. These may be cliches, but they work for me, and as long as I remember to apply these to myself as well as to others, I'll be okay. And so far, they have served me well. In fact, they can be reduced even farther to be compassionate or to love your neighbor as yourself. 9 years ago, I discovered the benefits of yoga. And Michelle Postenbaugh invited me to go along to a yoga class at Weber State. And I summoned up all my courage, and it really did take a lot, and I went. Okay? The very first class changed my life. It brought me a deep peace of mind as I practiced. As I lay in the resting pose called Shavasana at the end of class, there was a phrase that ran through my mind. And it was, there is another way. There is another way. And it took me a long time to understand what I meant by that. It was a revived feeling of spirituality that had long lain dormant, something that we all have to some degree, whatever our beliefs. Now, the word spirituality has a bad rap among scientists because we demand a worldview that's supported by evidence. We don't like anything that smacks of the supernatural. But spirituality doesn't have to be supernatural. No, by spirituality, all I mean is having a deep concern and respect for those who share this world with us, for being fully involved in the world, facing its problems directly, and doing what we can to help out. There's nothing supernatural about that. It's just the essence of my 3 rules. I wanted to teach yoga, and so I did yoga teacher training at Yoga Joe's in North Ogden. And when that studio closed, whoops, did I go backwards again? Yes, no, there we are. Okay. And when that studio closed, I opened up Ogden Sangha Yoga with my business partner, Kathy, and Vicky there on the left, one of our teachers at the studio. And teaching yoga gives me the chance to share my sense of spirituality with others as I read wisdom stories from many traditions. And so the universe certainly has a subtle sense of humor. 50 years ago, I considered being a pastor and talking to people every week about things that I thought were important, like love your neighbor as yourself. And now, after all that's happened, I'm teaching yoga and talking to people every week about things I think are important, like love your neighbor as yourself. Well played, universe. So, I'm a reasonist. I'm actually a reasonist with an asterisk because I know its limits. But as you can see there, reasonists, they believe in an evidence-based world, something called rationalism. But it's a tiny group, not so influential. Okay? being a reasonist may sound sort of Spock-like and bleak to you, and maybe you think that my view of the world lacks a sense of the mysterious. But I want to assure you, on the contrary, that my view of the world instills both awe and wonder. Einstein said that the most beautiful experience we can have is the mysterious. It is the fundamental emotion that stands at the cradle of true art and true science. Whoever does not know it, it can no longer wonder, no longer marvel, is as good as dead, and his eyes are dimmed. So what is the ultimate nature of the physical world, and what is our relationship to it? You know, I know we live in a dream, in an illusion, a world of illusion. This table right here appears to be solid, but I know it's really empty space. If I could remove all the empty space from matter, I could fit humanity into a sugar cube. As physicists and astronomers, we stand before the universe as we might stand before the Wizard of Oz. Right? We desperately want to see behind the curtain. We want to glimpse the ultimate laws, but what can guide us? Right? Einstein thought deeply about the nature of science, and he realized that the principles of a theory can't be deduced from experience by abstraction. That is, by logically complete claims of argument. He said that in the logical sense, the fundamental concepts and postulates of physics are free inventions of the human mind, and in themselves are completely empty as regards reality. He described the gulf, logically unbridgeable, which separates the world of sense experience from the world of concepts and propositions. In other words, there are names, but not nature in words. How ironic is this? The logic and the mathematics that work so spectacularly well within physics cannot be relied upon to extend it. When logic is inadequate to extend physics, what can guide us? Einstein insisted that we must rely on our creative imagination, on our intuition. And our intuition is far from infallible. We've been down the wrong yellow brick road before. Evidence from new experiments and observations may be fatal to our cherished theories. 2 revolutions in physics just happened a century ago, and they completely overthrew the foundations on which so much of the classical physics was based. Classical physics was only an approximation to the deeper view that was invented by the creative imaginations of Niels Bohr and Einstein. And they showed the way to quantum mechanics and relativity. The new ideas of modern physics cannot be logically deduced from classical physics. So today, here we are. We're confronted by an unknown dark energy and dark matter. Relativity is in conflict with mechanics. One or both of these must be modified, but we don't know how. There's just so much we don't understand. But here's what's important. You know, we scientists have learned to be comfortable with uncertainty. In fact, we thrive on it. We see these conflicts as invitations to make new discoveries. The discrepancies between the theoretical predictions and experimental results are only indications of the right road to take. And so as scientists, we have to freely invent concepts and postulates. And then we test those with experiments and observations, and eventually we come to trust those because they're based on overwhelming evidence. So the creative imagination and intuition have to be our guide. Logic will not do it. And somehow, I don't think fundamental progress will be made by bigger machines, but by cleverer brains. Surely there are clues all around us, and when we make the next big conceptual advance, we'll look back and say, why didn't we see it earlier? The clues were right in front of us. And to make these conceptual advances, we have to have courage to use our creative imagination and intuition to move beyond the worldview that we inherited as we all travel in time together into the future. With our new eyes that are informed by our creative imagination and intuition, we will be able to peek behind the curtain and to further diminish the illusion and discover wonders presently undreamed of. I'll end with a quote by the greatest experimental physicist who ever lived, Michael Faraday. "All this is a dream, Still, examine it by a few experiments. Nothing is too wonderful to be true if it be consistent with the laws of nature. Thank you.